Hello ladies and gentlemen, welcome to my video. Given y equals to a function x, however not just x but additional summation symbol for k, how can we find the area under the curve for x equal to 0 to 2? Of course, we can use integral calculus to find the area, but before anything else, we need to find a way to get rid of the k and the summation symbol. For this purpose, we need to use Taylor series. Let's split the y become two parts, both from k equals to 0 until infinity. For first part is x multiply e power k divided by k factorial, while the second part is k multiply e power k divided by k factorial. For the first part, x is not related to the k, which means we can move it outside the summation symbol. From here, we label y1 and then y2. Let's focus on y1. From Taylor series, we know e power z is equals to 1 plus z power 2 divided by 2 factorial plus z power 3 divided by 3 factorial and so on. Which means summation from k equals to 0 until infinity, z power k divided by k factorial is equals to e power z. Compared to the summation part of our y1, we can tell that z is equals to e, which means our y1 is e power e multiply x. Take note that e power e is a constant. Now moving on to y2. This is our y2. We can see that the k on the numerator and k factorial and the denominator somehow can be simplified. What we can do is we split the denominator from k factorial become k multiply k minus 1 factorial. The k are cancelling each other. However, the k must be start from 1 in order to avoid negative 1 factorial. Let's define n equals to k minus 1 or k equals to n plus 1. Now we have the summation, but for k equals to 1, n equals to 0. When k is infinity, n also infinity. And then e power n plus 1 divided by n factorial. N is just a dummy variable in calculus. We change it to k just to make sure it is standardized. So we change all the n become k. We can further simplify the equation become summation k equals to 0 until infinity, e power 1 multiply e power k divided by k factorial. E power 1 is just a constant. We can take it outside the summation symbol. The summation part looks familiar. That is because we already solved it during y1, which is equals to e power e. Therefore, we obtain our y2 without the summation symbol, which is equals to e multiply e power e. We successfully get the y without summation symbol and without the k, which is e power e multiply x plus e multiply e power e. Or we factor it become e power e and then multiply x plus e. The area is equals to integral 0 to 2 y and then dx, which is equals to a constant e power e and then multiply 1 over 2x squared plus ex for x equals to 2 and 0. Put in x equals to 2 and x equal to 0 into the equation. We obtain the area under the curve. That brings us to the conclusion of this video. The area under the curve solved by Taylor series and integral calculus is 2 multiply e power e plus 2 multiply e power e plus 1. Thank you for watching my video. Please continue support my channel, subscribe, give a like and share my video with others. I see you in my next video. Bye bye.